Today in class we talked about finding experimental probabilities. Hopefully you've had a chance to complete the problems on page 8 and now you can correct them with this section. Calvin's sister Kate finds yet another way for him to pick his breakfast. She places one blue marble and one red marble in each of 2 bags. She says that each morning he can choose 1 marble from each bag. If the marbles are the same color, he eats Cocoa Blast. If not, he eats Health Nut Flakes. Explain how selecting 1 marble from each of the 2 bags and tossing 2 coins are similar. So as we're thinking about this, it might help to draw even a little diagram. You're envisioning marbles inside of bags, so a red and a blue inside of each bag, and you're picturing 2 coins like we did in class today, where you can get heads or tails on each coin. So how are these similar? Well, hopefully today in class you saw that when we flip 2 coins, there are 4 possible outcomes. We could get heads and heads, tails and tails, heads and tails, or tails and heads. And hopefully with your teacher today, you talked about how those are 4 distinct outcomes. And so we're actually equally likely to get a match as well as getting a no match. When it comes to the marble situation, I might think about what are all my possible outcomes here. I could get red and red, blue and blue, red and blue, or blue and red. Those are also 4 distinct outcomes. So what we're hoping you're talking about here is that how each of these situations has 4 possible outcomes, and the outcomes are equally likely when it comes to getting a match or a no match. Edsila and Adahi have to decide who will take out the garbage. Adahi suggests they toss 2 coins. He says that if at least 1 head comes up, Edsila takes out the garbage. If no heads come up, Adahi takes out the garbage. Should Edsila agree to Adahi's proposal? Explain why or why not. Let's think about the chances that are involved here. So if they're tossing 2 coins, what are all the possible outcomes for tossing 2 coins? Well, we could get heads and heads, tails and tails, heads and tails, or tails and heads. So if heads comes up, at least 1 head, then Edsila is going to take out the garbage. So how many of the outcomes have at least 1 head? Well, heads and heads has at least 1, heads and tails, and also tails and heads. So Edsila has 3 possible outcomes out of the 4 that are going to lead to her taking out the garbage. Adahi only has 1 outcome, 1 out of the 4, that's going to lead him to have to take out the garbage. So I don't know, would you agree to this plan? I don't think I would. You want to talk here about how those outcomes are not equally likely, so it's not a very fair system. Suppose you write all the factors of 42 on pieces of paper and put them in a bag. We're going to start by listing all the factors of 42. All the factors of 42, we're going to be thinking about how can I make 42? You might have forgotten this, but a factor times a factor is a multiple. So we're looking for the little numbers that make up 42, the numbers we can multiply to make 42. So for example, 1 times 42 would make 42. 2 times 21. 3 times 14. And 6 times 7. Often it helps to list our factors in a list from smallest to biggest. So I'm going to do that here as well. 1, 2, 3, 6, 7, 14, 21, and 42. Those are all of the factors of 42. So now you're going to shake the bag and choose 1 piece of paper from the bag. Find the experimental probability of choosing the following. Express your answer as a fraction. And let's also try to use probability notation. So what is the probability of getting an even number? Well, my probability of getting an even number, I'm going to say P even equals. So looking at all those numbers up there, the numbers that are even, which are divisible by 2, would be 2, 6, 14, and 42. So that's 4 possible favorable outcomes out of a total of 8 outcomes. And I can also simplify that to 1/2. If you wanted to challenge yourself, you could also write that as a percent, 50%. Then we're going to think, what is the probability of getting an odd number? Well, P odd equals. So I'm going to think this time, how many of those are odd numbers? Well, 1, 3, 7, 21. Those are all odd numbers. So that's 4 out of 8, or 1/2, or again, 50% if you want to add the percent as well. What's my probability of getting a multiple of 7? So P7 equals, or actually I should say P multiple of 7. That's a little bit different. So again, thinking multiple of 7. So multiples, you want to think like a multiplication chart. So like 7, 14, 21, 28, etc. So looking up above, I can see 7. I can see 14. I can see 7 times 3, 21, and 7 times 6, 42. So that's also 4 out of 8, which can be simplified to 1/2, which is also 50%. The last challenge one is a factor of 14. Well, factors, again, are the numbers that make up another number. So what could you multiply to make 14? So I might think about how I make 14 by 1 times 14, 2 times 7, and that's it. So if I look up here above, I see 1, I see 14, I see 2, and I see 7. So 4, I'm going to say factor of 14 equals 4 out of 8, which can be reduced to 1/2, which is equivalent to 50%. Again, adding the percentages on is just an extra piece, but it'll be good to practice that as well. We'll see you tomorrow for more probability adventures.